What's up, guys? Welcome back to the shop. David Mizet Formula. Thanks for watching. Thanks for subscribing. Okay, so today I'm excited. I've got a new oil pump back from Peterson. I've upgraded the oil pump. It's called the R4, which is an external wet sump oil pump. It's the same pump that you'd find on the back of a dry sump pump. So it's the pressure stage, but it's upgraded. I've moved it up to a 1.4-inch rotors, had it rebuilt by Peterson so that we have more volume and more output so that the pump will have more longevity. So this is our new pump right here, the Peterson R4. This is our 12 AN inlet on the bottom, 10 AN outlet on the top. What this does is it sucks the oil off the bottom of the pan. Again, it is a wet sump, and it sucks it off the bottom of the pan with this 3/4 inch or 12-inch line. And of course you have your belt, which turns this on a sort of like a Gilmer drive pulley. It's actually called an HDT pulley. And it's pretty simple. Pushes it out of the top here, and you have a bypass on the side where you can turn the pressure up and down, in addition to the internal bypass on the motor. Now, the reason I know that the pump was working really hard is because the last pump right here, this is the old body from the last pump. This last pump right here was going balls to the wall to deliver the pressure necessary. You had to put the bypass on the pump turned all the way in, which means this screw right here pretty much had to be knocked all the way in, which means the bypass is pretty much shut and the pump was running full blast all the time. And that was necessary in order to deliver the pressure that the engine wants. So in other words, it was using the internal bypass on the engine with this thing maxed out 100%, and you're still barely hitting the 125 requirement, which is fine. You're hitting the 125, not an issue. You have perfect oil pressure, logs look good, everything looks good. But you know you're working the pump really hard if the pump's external bypass itself is not even open at all. And so when you take the pump apart, everything looks good. Then you pull the rotors out. These are lobe design rotors, aluminum on aluminum, which kind of works against you for longevity. You know, it's Billet. Everybody's all fancy about Billet. They think Billet's like the shit. You know, Billet's pretty cool. But the problem with Billet is that although it's stronger and denser than porous aluminum cast, it's still aluminum. And so unless it's billet steel, being that it's aluminum, you've got an aluminum lobe and you've got thrust wear pushing this aluminum load against this aluminum housing. And what's going to happen over time? You're going to get grooving. You're going to get wear. And so you can see that wear. Let me tap the phone. There you go. You can see that wear inside there. So you see where the hole is right here. This is the main shaft. So the main shaft right here on the new pump rides through this lobe, and that main shaft is what's taking all the load and all the pressure, and it's worn down. So I can get my fingernail in here and scrape it, right? And so on a pump like this, any sort of clearance like this, extra clearance from wear, is going to take away from your performance. And then, of course, what's that going to do? Load it down even more. And then eventually you're going to end up with oil pressure drop on the top end if you don't catch it early enough. So what I've decided to do is, rather than, I could change the pump out to a G-rotor design, which is also a very efficient design, but a G-rotor pump runs a little bit hotter, it puts more heat into the oil, and they're also made of steel, brass, so they're also more reliable, they're more durable, they can last longer. But again, they're not quite as heat efficient. They put out more heat energy, and they're also heavier. So, and you also got to get a larger one to make the same amount of flow and pressure. So rather than switching the design up, which would require that I have to remake the alternator bracket, possibly redo the intake charge pipes, redo fittings and all that stuff, as simple as it sounds, now you're getting into weeks and weeks, months and months of work over something simple like an oil pump. I'd rather just try to stick with what we've got. Like I said, it's something that's really easy to get to. You can keep an eye on it, and if it works out, great. So this pump right here that we were just checking out, the old one, is a standard model pump. It's designed for standard piston engines, like maybe a 350-inch motor or whatever, okay? But they also offer a larger pump that's 20% larger in lobe width. So the section of the pump body itself is 20% longer. And by doing so, you get almost 20% more output. And it's called the high pressure, high volume pump. So I've upgraded this pump to the high pressure, high volume pump in hopes that by having excess volume that I'm not going to use, because I'm already going to be hitting the internal regulator at 125 psi. That will allow me to back open the bypass on the pump. Now that excess bypassed oil that's not being utilized by the motor will go back into the inlet of the pump and increase its efficiency by 20%, which means it's 20% less load on the lobes and the housing. So if you want to think about it in another way, you can say, okay, the pump is 20% larger. So for every revolution of the pump, it's drawing 20% more oil in than the last pump. Because it's drawing in 20% more oil, it's going to hit its requirement earlier. And the excess fluid that's not being used by the motor, since we've already hit the motor's requirement, is going to go back into the inlet of the pump, increasing its efficiency by 20% and decreasing its load by 20%, which means now it's not going to have as much thrust pressure on the front of the housing, meaning that the pump will become more reliable and will last longer and have a longer life. Now, I don't expect this thing to be 100,000 mile pump. I just don't. It's a race car pump. You know, if you talk to machinists that have been in the industry for a while, I don't want to mention the guy's name, but he did a lot of work on the car. I'd love to mention his name, but I don't want to. He might not want his name mentioned. He's done a lot of work on the car, did a lot of stuff for this engine that's tremendous, and I respect him a lot. And he's also done some awesome replica or re-engineering of like dry sump stuff that's not available for the FD. And so until now, you know, because it's discontinued by Mazda. And so I really highly respect his opinion, and he's told me the same thing. He said aluminum on aluminum design, although it's billet, is still going to wear out over time. It's not intended to be a street car. It's intended to be a race pump that's highly efficient, does the laps, does the performance, and then you throw it away at the end. So if I can make it a year banging this thing off the limiter, driving it to 10,000 RPMs, making double the oil pressure of a typical engine out of a standard pump, then I have high hopes for a high volume pump that can do the same thing, right? So let's see what we can get out of a high volume pump. If it wears out, it wears out. If we check it out, it looks like it's a little bit too, you know, depreciated in its life, then we'll just go ahead and swap it up to a new design. But for $200 to $300, I can rebuild this pump and have exactly what we have sitting right here, and we're ready to go. So let's go ahead and throw this thing in the car, and let's see what we got. I'm going to show you the assembly process of how the rear drive and all that works, and we'll be good to go. So this is our 3-bolt flange that goes on the back of the pump, and this 3-bolt flange allows us to adapt this piece, which is our adapter for the fuel pump drive cable. So I'm going to go ahead and install that, and once we get that installed at the back of the pump, you can see when the front of the pump turns. See this? You turn the front of the pump as if there is the pulley on it. This rear drive, which is a hex drive in the rear, turns as well. And when this rear hex drive turns, see if we can get my camera to focus here. There we go. When this rear hex drive turns, that turns the male hex for the fuel pump. So you got to put this little adapter right here on the back side and then bolt this guy to it. And he sits right off here on the back, and then you can screw the fuel pump drive cable into this. So that's the nifty part of this process. That's why I absolutely love this setup. There's just a little bit of Loctite on these bolts, and that's just so we don't have to worry about them backing out. We don't have to use a whole lot of torque. And then they go right on the back of the flange like this. guys, so we got everything reinstalled on the car, and it's running great. I'm seeing about 127, 128 pounds of oil pressure. The only thing that I don't like is that I had to use a dowel instead of the springs on the oil pump. That was what was recommended by the oil pump company, is to put a solid dowel in there to block off the external regulator so that we're using only the internal regulator on the engine. And it just doesn't, now I don't really know how hard the pump is working, but I'm seeing a good 128 psi at 160 degrees Fahrenheit oil temps. When it gets up to about 100, 210, 220, the oil pressure comes down to about 122, 123, 125, somewhere in there, depending on the RPM. So running great, running solid. Everything's looking good. My eyes are watering because this thing is so I don't know, it's just the E85 fumes, man. But anyways, I got to get out of here before I choke to death. So thanks for watching. I think what I'm going to do next is upgrade the 12 AN line to a 16 AN, take some load off the pump, and see if we can't put the spring back in and use the bypass again, but we'll figure it out. Anyways, thanks for watching. Appreciate it, you guys. Things ready to get back on the road and rip, and we'll talk to you later.